Okay, so this is for people who've kind of outgrown Dialplan or just want to add more to Asterisk. Actually, I put this in there. Before I start, if you're a Linux engineer and you're looking for a job, we want you. So you can talk to me after the show. So we begin with outgrowing the Dialplan. And if you've wanted to do some advanced development and there's just something that is just not there in Asterisk, and you can't really do it in Dialplan, you got to start diving into the C code. So I'm not going to bore you guys with too many diagrams and things like that. I'm just going to jump right into a whole bunch of code. And I don't really expect you to really follow every single last line because a lot of it's my specific requirements, but I'm going to go through some concepts and items that you're going to need for developing apps. So the first thing you're going to want to do is if you want to interface with a channel, you need to add hooks to the Dialplan, which is applications and functions. So functions are, if you're familiar with group or any of the channel set caller ID type of things, that's all functions. If you want to use a value from a function, you can do so on Dialplan with set, which you're probably familiar with. And if you want to give up control of your Dialplan to, let's say, voicemail, dial, you'd use an application for that. So really, behind the scenes, they kind of really make no difference. You can use an application instead of a function, or a function instead of an application, because really it's just a callback. But keep this in mind if you want to get your code into Asterisk mainline. So I'm going to give you some examples right away. Can everyone see? Let me make this a little bigger. So, so back to what I was talking about with a custom function register. So if you want to make a new function in Dialplan, you're going to use something that looks a little bit like this. And a lot of these bits of code you could find right in the Asterisk source. Like this is ripped from some code that I wrote that's going to be in Asterisk 12 for groups. And actually, group count is already in there. But there is some group variable stuff I'll go over. So let's just say you're implementing group count. You need to define this structure and define a callback. So this is the thing that's going to be running when your channel is executing the Dialplan. So you don't have to really know what this stuff does, but basically your syntax for the group is going to be, your set group equals group at category. So this split group takes those things and puts them in separate variables, and then gets the count of that group at category. So this is just a tiny little bit of code that adds so much power to Asterisk. Now you don't have to dive into the C code all the time. You just use this from Dialplan. And to go over applications, if you're going to write your own version of Dial or something like that, write your own voicemail system in C, you're going to use this register application. Now these XML functions, or the newer breed of functions, you're going to put your documentation right in the file, which is pretty cool. And I could show you that in a little bit, but here's the code. So I'm going to implement this application called dump groups. So if I put that in my Dialplan, it's just going to run this bit of code. I don't care about the result because it's going to dump this to the console. So in your load module, you're going to use this register application XML, and you're going to define your name, which is this dump groups app, which is just a string. And you're going to run this callback function, dump groups exec. Now this just prints out all your group information. So if you've looked at any of the group code, this should look pretty familiar. But this is a new feature that I wrote to print out all your groups from Dialplan. So if you're debugging a system, you could add some hooks to say, well, if this and this happens, I want to dump all my group information just for debugging. So this is how you do that. So this is the callback. You're going to define dump groups exec, and it takes a channel. And your data is actually the parameters. And you'd parse out the parameters using the built-in functions for that. This doesn't take any parameters. So That's not needed for here. But basically, a little loop prints out some data to the console. It uses a linked list, which you'll notice. I'll talk about this in a little bit. Definitely don't reinvent the wheel if you're developing C code for Asterisk. There's a lot of tools. There's linked lists. There's objects like the AO2 objects. Will give you a lot of power. So moving on to some other items. CLI commands, if you want to add things that you're going to type into the console. And you could just make your life easier by adding code to the console so you don't have to run it from Dialplan or the manager. So your code is going to look a bit like this. Asterisk CLI register multiple. Why it's multiple, I don't know, but it allows you to register multiple CLI commands in one go. So here's some functions I made. This is for a custom module that I wrote called tie. How it works exactly, you don't really need to know. But this particular CLI implements two commands, tie show channels and tie set. And here's the callbacks for those. So all the interesting thing about CLI commands is that you're going to put the syntax right in that function. So this is an example of a fairly simple debug on, debug off type of thing. Here's your parameters. It takes a handle to your CLI session, the command, and the arguments. And then each command is totally independent, which is pretty cool in implementing its syntax. So you put your syntax right in the function. And this arrow command, this will give the command completion. When you hit tab, it looks at this string. And it will complete it for you based, and these are very specific bits of syntax, which can be looked up in the documentation. The parentheses, angle brackets, curly braces, all mean different things when you're implementing a CLI function. So you do your parameter validation, you do your thing, you return success or failure. And this is a pretty simple, on-off debug type of thing. But you can do a lot of extra functionality, such as my show channels. So this just runs a function which isn't in this code snippet, but as you can see, it's the same type of syntax. You're going to write your command string here, tie show channels. You put your online help right in there. Oh, OK. Not better. Sorry about that. OK. So it just runs a bit of code. I could show you this in a little bit. But functions and applications shouldn't really seem all that scary just because it runs just code. A lot of the hard stuff is just really taken care of for you. You implement your load module, and you define what your module is going to export, functions, CLI items, manager items, and the system just takes care of everything for you. You don't have to worry about parsing, command line. Well, you don't have to worry about getting your stuff into the command line. It just puts it in there for you. And on to the next item, manager commands. So you really want to keep in mind that people using your app are going to use it in a lot of different ways, especially if you're going to get it into mainline. So anything that's in the manager, you're really going to want also in the CLI, if it makes sense, like meet me commands, meet me kick, meet me mute. They should be in the CLI, should be in the manager. So keep that in mind when you're writing code. And here's some manager examples. Go on to our next file. So here's an example of the documentation. This is the new style documentation where you write some XML in your C code. And there's some information on the wiki about how the syntax works. So I'm not going to go into too much detail. But this is how the system knows when you do core show application, manager show command, et cetera, where to get this information from. So back to our familiar load module. We're going to implement this group show variables command. And you can see this code on the review board. And this is the bit. It's going to be an Asterisk 12 next year. So I'm going to register a new manager function using the XML help. And this is some other information. The parameters are like what sort of reporting do you want in the manager, and then you could look at the help in the header files. And here's your callback. So we're going to go to that. So your parameters are pretty simple. It gives you the session pointer and the message that got passed. The pointer to the message container, which will contain your arguments and things like that. So keep in mind that people are going to want to use action IDs. So an action ID, if you're not familiar with, if you're having a manager session that's handling several different commands at the same time, you're going to do asynchronous originates, things like that. You're going to want to pass it an action ID to track that this originate was successful or that other command was a failure of some sort. So you're going to handle the action ID. This isn't done for you, so this is just a bit of code that you're going to have to put in to manager commands. And again, you don't really need to know exactly what this does, but it makes a output list of your group information along with the variables. And a lot of this, if you're interested in learning how this works, look at something like meet.me or look at something like funcgroup. They're pretty simple modules in terms of the commands. You don't know you don't have to know how the meet.me itself works, but just look at the command handling. And a lot of this stuff can be readily available. You could just copy and paste some bits of code from meet.me and make your own commands. So it loops through here, sends some events, and basically returns 0 for success. And really try to clean up after yourself. Definitely free all your items. Some of the things now are reference counted and they'll be freed for you, but even with that, make sure you keep your references up to date. And on to the next item. So the problem that was happening before with CLI commands is that every module just kind of like had 20 different core CLI items. So try to put everything into like one umbrella. If you're going to do a new feature for SIP or something, or new feature for a new channel driver, put it all under one command. So if it's SIP reload, SIP refresh, SIP this, SIP that, try not to pollute the namespace. And that'll help you get into mainline better if you're interested in contributing. So what do you do when you want to store some data about your channels? There's a built-in thing called Datastores. And you could allocate free search, and it's a really, really handy item to be able to just store any kind of arbitrary data about a channel or anything else without having to add to the channel structure in channel.h. So go on to Datastores. So the first thing you're going to want to do is define your data store types. I don't know if this will fill the screen. OK. So the most common way is put in structures. And you're going to store your structure in the bit of data that's allocated by the data store functions. And usually you'll have a linked list or AO2 objects. And you're going to define that all in your file. And also define your core item that's going to be stored in the data store. So you're going to have, generally, how you organize it is one structure where you're going to put that in your data store, and then you're going to allocate everything inside that structure. What that means is when you do your allocate, you're just allocating a chunk of memory for whatever you're going to store. So when you do your initial allocate, you're going to allocate your structure, which is going to be a container for, let's say, a linked list, or a container for, let's say, an AO2. It's not really a good idea to just allocate like an AO2 and shove it in a data store, because it's not very flexible. So just shove a whole structure into the data store. And so when you're going to add a data store, there's a couple of functions to know. So alloc just kind of adds to a general global linked list of data stores, and it will tag your data store with a token. And that's defined up here. So you're going to define a structure of type AST data store info. And in that structure, you're going to have a type, which this is the token that I was talking about. So if you want to find your data store, the cool thing about data stores is you can access them from any channel, any module, by name, assuming you have this structure information. And then there's associated callbacks, such as cleaning up your data store when the channel goes away, fixups, which I'll talk about, what happens when a channel gets masqueraded, And duplicate is when something like a dial happens. If you want to transfer data to your child channels, you'd use duplicate. So data store find is what I said before. You could locate data stores. You'll get back a pointer to your memory as a void pointer. So you have to know what it is to access it. And then removing, definitely do your removals, hook into the hangups, and clear up your data when your channel goes away. And of course, free. So that's that bit. On to the next slide. Fixups. So this is what I talked about with masquerades. When you have an attended transfer, like a SIP replaces transfer, a masquerade is going to happen. Do you want to preserve any data when that happens? If you do, you're going to want to run a fixup. If you don't define it. So we can go into the code for that. And I'm kind of flying through this just because we have 30 minutes and there's a lot of data. But if you're interested, you can send me an email. I could walk you through some more items and send you some good information sites. So a fixup is going to be needed, like I said, when a channel gets replaced of some sort with a masquerade. So you're going to define a .chen fixup element in your AST data store structure. And this is just a snippet. This isn't the whole AST info. I just broke it down to make it a little shorter. So when in the fixup, you got to keep in mind a certain thing in your head where is this data going to go? Do you care about the data that's on the new channel, or do you care about the data that's on the old channel? So that makes a lot of difference. Again, you don't really need to know specifically what this code does, but you're going to get this data pointer in your fixup is a pointer to the data store, and it's a void pointer, so you'll get back your memory that you allocated. You'll get the old channel and the new channel, and what you want to do with it is up to you. But this is really important if you want your data to survive across masquerades. And I do some list traversals, do some debugging, and definitely do your debugging at a module-specific level. Like, don't just write to AST verb 3 for everything, or 2. Or I have this tidebug flag. So we're trying to really make it so that things are independent. So if you care about just SIP, you turn on SIP debug. Well, if you turn on core debug 5 or something, you get so much data that it's hard to sift through it. So try to keep your debugs modular. I do a bit of more traversals, do some fixups. So basically, to do a quick little explanation, I have a named item. So I track channels by a pointer. So I needed to know about, is this channel going away somewhere? Like if A calls B, and B is transferred to somewhere and has a masquerade happen to it, what happened to B? I need to reference that. So I created this thing called a tie. So what the masquerade fixup does is you have your source channel A, your destination channel B, and your transferred channel C. This fixes that link because A is going to go away because B is going to now talk to C. So this little diagram, if it makes sense, will explain kind of how that works. So it basically unties this pointer to the B, moves it to C instead, so that you maintain that link. And some more list traversals, don't need to worry about that. And the other item for callbacks is duplicate. So you're going to need this if you want to inherit data. So let's just say you're dialing an agent. So you have a call queue, perhaps. We wrote our own call queue. We use this a lot. And you have a caller ringing an agent. Well, the agent channel is going to want to know like what the caller channel is. So you could preserve that data with a duplicate. So it's a pretty simple function. It just takes a void pointer of what your data store is, and you're going to define this .duplicate to run that callback. If you don't need that functionality, don't implement it. It's better to not have the code than have a no-op. So we're going to run through some duplicate code. So this is back to my tie module. So what I wanted to happen was you have A is linked to B, and basically A is calling B, actually. So A is going to be the let's just rename these to caller and agent. So the agent channel, I want to store the caller information on the agent channel related to this tie object that I created. So this duplicate is going to copy. So I have a tie item on here, and I'm going to copy that to here to have the same tie information. And what that means, again, doesn't really make a whole lot of difference. It's the concept that we're working with of this duplicate is going to clone the data of your item, usually a data store. It's the most common. So in this duplicate full callback, I wrote this duplicate full because the regular duplicate just passes you a void pointer. So I needed some more parameters. This will hopefully be an asterisk 12 because it passes the from data store, the from data, your from channel, the to data store, and the to channel, which is a lot better. It's a lot easier to do your duplicates when you are given the source and destination channel rather than just your data store. So we could just kind of run through this real quick, but I'm copying my tie entries from the source to the destination. I'm cloning them. So for each one of my from, which is my linked list, I'm traversing. Ooh, mouse cursor is freaking out. For each one of my from entries, I'm going to create the same entry on the to. So in your duplicate, it doesn't necessarily have to be a data store. You could have some sort of global variable that's protected by a lock. It doesn't really matter what the data is. You could copy it in this function. On to the next item. So this is what I was talking about before. What you do to store your data really doesn't matter a whole lot. You can use data stores. You can use a global variable. There's a lot of existing functionality. Linked list, AO2 has a lot of cool stuff like hashes. Definitely make use of those. So I put deadlocks in here, which if you've done any development for Asterisk, you know what that is. So a good, really simple way to avoid deadlocks, and it's a bit of an efficiency hit, but it's basically the most straightforward if you're just starting out, is put your code that manages any kind of data in I call it just a big lock. You know, it's kind of like the big kernel lock from the yesteryears of in the Linux kernel. So you do your lock, you do your data manipulation, you do your unlock, and there should be one place that happens. Deadlocks happen when you have A is wanting a resource from itself and another item. So A is locking A and B, and then B is locking itself and wants A, so now you have A locking A and B. B is locking B and A, and now they're both waiting for each other. So definitely avoid multiple locks if you can. Just the easy way is just have one master lock, do your data, unlock it, and you're done. So what's the time? OK, so we got some good time for Q&A. Here's some good lists, list of resources. If you want to start participating in development or just get some help, Asterisk Dev on IRC is a really awesome resource. There's a lot of people who really know the core of Asterisk. And definitely head to the website, the developers URL, and the wiki. There's so much information. And these slides will be published online for you to look at. But the gist of it is, since it's so open, just dive right in, add what you need. And if you think that the community could use it, push it back and try to get it into mainline the best you can. So questions? Yep. That's, if you click on community/developers, that's one of the items. So what was that? OK. Yeah, some of the code is left in there for debugging, and some of this code isn't part of my commit for mainline. Yeah, it does violate some of the guidelines, putting some long statements on one line, things like that. But yeah, definitely follow the guidelines. Yep. Yeah, no, I'm aware of that. Other questions? Anyone have a particular project they're working on that they just don't know what type of method to use or what structures are there for help? Feel free to throw up a question or two. Okay. So, yep. Okay. So who here has either dived into the Asterisk source and written stuff, or is in the process of? So, a couple of hands. This is, like the title said, a bit of an advanced talk. So if you're not already a C developer, this probably didn't make a whole lot of sense. I do apologize about that. So I can go over some items. In my description, I said we'd go over some concepts. So I have a group count, which I was working on. So the process of developing this was I needed a way to store metadata about a collection of channels. So you know how you can store a variable on a channel, and you could put a channel in a group. Well, I thought, wouldn't it be awesome if you could put variables on a group of channels? So if you join 3 channels together, they all share the same data. Those 3 channels go away, and the data is gone. You don't have to worry about cleanup. So yeah, you can use ASTDB to store your data, but then you got to implement some hang-up handlers and make sure your data is cleared. What if Asterisk restarts? You can have stale data. So these group variables are pretty cool for that. And I used a lot of the techniques and functions that I just talked about, registering some manager commands that weren't there before, group set, group remove, and setting some variables. So if you're interested in getting into this stuff, it's a really good resource to just poke around in the function modules, and the wiki is some good information. The interesting part about group count was the core of it is actually in Asterisk core. A lot of these things you'll notice, like group var get, the functions that do the actual setting are a built-in AST app. So it's a little tricky, like where to put your code. It's a bit of a trick to know, does it belong in a function module? Does it belong in app? Does it belong in res? Does it belong in core? It's really hard to tell sometimes. If your thing implements just functions, kind of going on a little bit of a tangent, but if it's just functions and just managers, do it in func. And if applications that happen to implement functions, you could split it up into 2 separate modules. So back to where we were. So this AST app group var, AST app group get var, is actually implemented in main app.c, which I could load up real quick. Don't have this on my hot list. So we're going to search for this function. So the reason why it's in here is because Asterisk core uses groups. So that's why it's in this app.c, part of the Asterisk core, not actually part of the module. Try to stay away from putting stuff into core if you could avoid it, because there's plenty of callbacks. There's things like Datastores, and you could use Datastores for some cool things like tracking hang-ups and things like that. You could add a Datastore, and back a couple of slides. Maybe it's not in the slide. Part of the Datastore definition, 5, is your free. So free gets called when that Datastore gets destroyed. So if you want to do something like interesting, like track a hang-up in some custom way, hook into the free of your Datastore, allocate a Datastore, put your Datastore on the channel that you're interested in, and define a .free. And that'll take care of tracking that for you. Back to func group count. So there's a lot of cool stuff that working on adding to group count. So like this application, like dump groups, this is what I talked about before. If you're interested in debugging, you have dump chan. You go through your Dialplan, something weird happened, you do if something weird happened, whatever that condition is, do a dump chan. So this is similar. And it's a good idea when you're developing a module to put in what we call introspection. Be able have the module be able to inspect itself for consistency, dump as much output as you can. That makes sense. If someone needs to be a hardcore developer to understand it, it probably should be an advanced verbose feature. But for the regular human user, well, I have to be human, I guess. It helps to be pretty generic in your output. So in my dump groups app, which is here. Oh wait, no, I need the callback. Dump groups exec, and naming conventions are interesting. Try to keep that in mind, and a lot of those things are in the coding guidelines. So in dump groups exec, like I said before, put out output about what your module is doing if you can, because I hate downloading some third-party module where you load it and it says it failed and you have no idea why, or you load it and it looks like it's working but you still have no idea why. Did it load the configuration? What is the configuration values? Definitely add that to your module. Print out your working data if you can. So this is a fairly simple function. So we get our, this is the start of our callback. We get our command starting processing on this particular channel. We don't necessarily need the channel for this application, the dump groups, because it's going to be dumping all the groups. But you can use your specific channel. If you do anything with your channel, make sure you lock it, and make sure you unlock it, and make sure that you're not in conflict with some other part of your module which might be locking your channel. That's a whole nother talk, is avoiding deadlocks. So it's just going to print out the name and category of the group, and that's about it. So you'd know what channels are assigned to what groups based on this dump groups app. And some other functions. I added this group match list. Another cool thing is regular expressions. Try to make use of them when you can if you're doing any kind of channel matching. So I have a group match count. So this is like a wildcard search for a particular group. So if you want to see how many channels I have that match group foo.star, this would take care of that. So in your function, you define a read and a write callback, which I actually didn't go over previously. Function can be used in set, or a function can be used as a variable. So when it's used as a set, you got to define the write callback. When you're using it as a variable, if you're just doing a thing like this, if you're using no op, channel caller ID, that's a read function. And then if you actually wanted to set this equals, that would be the write function. So when you define something like a read, a lot of these things are pretty similar. You'll get your channel, you'll get your data, which contains your arguments, and you get the size of what you got. And then this just does an internal function, which again is part of the core. And should be straightforward. Compiles regex, and for each channel in my groups list, I'm going to traverse my linked list and match, to see if I got that, and bump up a count if it matches, return my count. And let's see, dump groups. Yeah, I think we covered all the aspects. Basically, there's just three major aspects: Dialplan, CLI, and manager. So, any questions on that section? No questions. So you guys are all experts then. So don't really have a lot more data. If someone maybe doesn't have a question but more of a statement, you could bring that up. Man, tough crowd. Oh, OK, in the back. Yeah, so the question was, how do you make sure, basically, how do you make sure you didn't break Asterisk? How do you make sure you didn't slow down Asterisk and affect other applications? As with pretty much all programming, it really just depends. There is an Asterisk test suite. So I mean, that's your first and foremost test. Download the test suite, run it against your new code, and if it passes, that's great. What that means is that it didn't break anything that was tested for. It doesn't mean you didn't break Asterisk, because there might not be a test for the thing you broke, that's just programming. So what we do is we have a test suite. We don't specifically use the Asterisk test suite. We wrote our own, but we've developed a testing language that spawns calls. We'll check data in Asterisk. We'll query the manager for, I started a channel. Did it really start? I made a call to an agent. Did the agent really get a call? If you have 5 agents logged in, did that first agent really get the call if it's round robin? That sort of thing. So it's really up to you in your own system how you want to handle that. You need to write for every code, every line of code you write, you're going to wind up with 10 lines of code to test that, just because there's a lot of different situations that you'll run into. Like you were saying before, in different scenarios, you might have 1 call and you're fine. You might have 100 calls and the system blows up. So, as usual, it just depends, and it's up to the user to really, write the code. In this day and age, tester-driven development is definitely the way to go. Which doesn't necessarily mean write your tests beforehand, but definitely test in an automated way. And the Asterisk test suite is a really good start to that. And it's, as the year goes on and we go into next AsterCon, you'll see a big, percentage of Asterisks being tested in an automatic fashion. Any other questions?
Where in the source tree would you put if you see any of this stuff? In the source tree, and when you make your file, when you make it, do you have to modify a make file? Do you have to do that, or you just drop your C code in a particular folder and then it picks it up from there?
Yeah, so the question was where do you put your code, which is a good question. So the make files are written in a really nice way. So if you drop in a new file in funcs, like you call it func foo, the make file will build it. It'll add it to make config, so you could enable, disable that module, the make menu config. So yeah, if you write a new, like func group count is in there. If you write a new app, make coffee thing, you could drop that in, and then you run make, and it'll build it. So generally, the naming convention is if it's an application, if you're writing something like dial, or you're going to do something that takes control out of the dial plan. It's going to sit in an app like an IVR or a mixer of some sort, like a conference bridge. It's going to be an app. Functions are going to be if you're going to change caller ID, if you're going to do some sort of call route settings, if you're going to change a channel parameter like music on hold. Those are functions. They do a quick little thing and you're done. So keep in mind that functions should be short running. In your dial plan, you should be able to use a function and a debug statement, get the result, move on. You don't want to hold up Asterisk. Some sort of thing like a background, like CDR is a resource module, like res, features and things like that. So if it's a resource module, it's going to be doing its job in the background. So that would be the naming convention for that. So you'd put it in res. If it's going to be some sort of just job that's going to be sitting there waiting for something to happen, it's going to be in res. So to answer your question?
Where is in the tree? When you download the source.
Ah, OK.
Yeah, that's
So if everyone could, oh, I think the left side's cut off again. My mouse is really weird. Some sort of interference. Okay. Well, I think you could probably. Don't bother. Anyway, so in Asterisk, I have a various amount of checkouts. But your checkout is going to look like this when you download the source. So you're going to have res, apps, func, or it's actually app. Apps, yeah, with an S. So in those are going to be your source modules. So let's just say funcs, for instance. In funcs is going to be anything func underscore that you're working with. And right in there is the compiled output code. When you do your make install, it copies these .so files into your installation, lib modules asterisk, or lib asterisk modules rather. So it copies all these SO files. You don't have to worry about installation. So when you build your module, you build your C code, you just pop it in there. I could make a new file, func foo.c, do my load module, and the parameters that are required. And I save this, run make, and it'll build it.
What happens if you have a duplicate name? Would it recognize that you have like a command that you duplicated?
Yes, yeah. If you do, that's part of the registrations. So if you do custom function register, it'll complain that it's already registered. So the cool part of this plugin system is a lot of this hard stuff is really taken care of for you, like naming, detection. Like if you're trying to override a built-in, it's not going to let you. And it handles, if you implement your unload, implement your unload module, and you unregister all these things, you type module unload your module, and Asterisk will take it out for you. Was that a question? Okay. So any other questions? Man. You're all sleeping, end of the day? I think I end at 4:15, so if that's everything, I guess feel free to grab some food, cookies, whatever we still got in the expo, and have a good rest of the Astricon.